Physics Part 235. There is an important link between the electric field at a point and the potential at that point. The field strength is equal to the negative of the potential gradient at that point. Thus, if we have a graph showing how the potential changes in a field, the gradient of this graph at any point gives us the numerical value of the field strength at the point, as we see in the figure. This link leads to an expression for the potential at points in the field of a point charge Q. The potential V is given by V is equal to KQ over R is equal to Q over 4 pi E0 R. The potential very near a positive charge is large and decreases towards zero the further away we move from the charge, which is the source of the field. If the charge producing the field is negative, the potential is also negative and increases towards the zero at large distances. Note that the variation of potential with distance is an inverse proportionality and not the inverse care. And that is not the inverse care relationship that applies to the variation of field strength with distance. We've got an example how much work must be done by an external force in moving a charge Q of plus 2.0 u c from infinity to a point A, 0.40 meter, from a charge of Q of plus 30 u c. The work is simply the charge. The work is simply the change in electric potential energy. The potential energy at infinity is zero, so W is equal to QV, Q is equal to QK, Q over R, 2.0 into 10 to the power raised to minus 6 into 9.0 into 10 to the power raised to 9 into 30 into 10 to the power raised to minus 6 divided by 0.40 is equal to 1.4 joule. Now it's your turn. 2 plus 30 UC charges are placed on a straight line 0.4 m apart. A plus 0.5 UC charge is to be moved a distance of 0.10 along the 0.10 meter along the line from a point midway between the charge. How much work must be done? In the case of a uniform electric field, such as that between two two parallel plates as shown in the figure, the relation between the field strength and the potential gradient is very simple. The potential decreases uniformly as we move from the positive left hand to the plate to the negative right hand. If the left hand plate is at the potential plus V and the right hand plate is at potential of zero, the graph of potential against distance is shown in the figure. It is a straight line sloping downwards with gradient minus V over D. This gives the negative of the potential gradient as plus V over D and has been stated above this equal to the field strength E, a constant because the gradient is constant. This is the same relation that was derived on the page 287. Graph of potential A and B negative and the potential gradient for a uniform electric field.